All right, for this lecture, if you missed, it was for the molecular model. And so the first slide on those slides is just a spot for you to take notes. Okay, so I'm going to talk about a couple of things that you need to know to be able to fill out the remainder of the assignment. The idea is that you'll take notes on that information and then use that information to answer the remaining questions. Okay, so the first thing we need to consider is how is it that molecules are formed? If we have just a soup of atoms everywhere, how do they form together to make molecules? Okay, and the way they do that is they form bonds between one another. Okay, and there are two names to these bonds. There are covalent bonds and ionic bonds. Okay. Now, to understand this, you need to understand that there's a point at which each atom on the periodic table would be satisfied with how many electrons it has, and there are only 6 atoms that just naturally are in that state where they are satisfied with the number of electrons they have. And so these atoms will do different things to attain that level or that number of electrons. Okay, for instance, we have hydrogen, which is the smallest atom. It has 1 electron, but it would be happier if it had 2 electrons. Well, we have 1 hydrogen. It comes in contact with a second hydrogen that also has 1 electron. Now, each of them have 1, which means between them they would have 2, and so they actually will share those electrons between each other, so that in total they end up with 2 electrons. Okay, 2 electrons that orbit around both atoms. Okay, so they both get to feel like they have 2 electrons. This situation I've just described, this sharing of electrons, is a covalent bond. So a covalent bond is formed when atoms share electrons. Okay. Now, not everyone is very good at sharing. Some atoms they don't share at all. Some they have more than they want, and so we have ionic bonds are not shared, but when atoms give away electrons or take electrons. Okay. One example of this is when we have, let's say, sodium, Na, which has 11 electrons but only wants 10. Okay. And we have chlorine, Cl, that has 17 electrons but it wants 18. What happens is that sodium will actually give away 1 electron to chlorine, making it so that sodium now only has 10 electrons, which is what it wanted, and chlorine has 18, which is what it wanted. Now, the thing that happens here, we need to consider how many protons and electrons each of these atoms have. Sodium naturally has 11 protons, which have a positive charge, and 10 electrons, which have a negative charge. If I add those two charges together, I end with 1 positive charge, meaning Na, sodium, is now positively charged. Chlorine naturally has 17 protons, which are positive, and now has 18 negatively charged electrons, causing it to, when we combine those charges, to have a charge of -1. So that means the chlorine has a negative charge. Now these two right here, they just, because of their charges, are like 2 magnets. They just snap right together and combine to create sodium chloride, or table salt. Okay, and that's the common name, is table salt. So ionic bonds isn't just the giving or taking of electrons. They give or take electrons, creating positive or negative charges. that attract the atoms together. Okay? Now, that's how atoms form together to make molecules. Now, molecules have different properties. Okay, and different molecules have different properties. I'm not going to go over all the different properties that could happen. We'll actually do that in a later time, but we do want to discuss properties of molecules, as in what things affect the properties of molecules. Okay. And we've got three main things we're going to look at here. The first is the bond, the type of bond, whether it's ionic or covalent. Okay, that would affect their properties. Then how stable the bond is, the molecule is. Okay, for instance, hydrogen is not super stable, okay, and neither is an oxygen molecule. And what will actually happen is, we've seen this in class, I talked about it in the last video, that hydrogen, when introduced to a little bit of heat in the presence of oxygen, well, that hydrogen will actually break apart, breaking these bonds, okay, like that. And the oxygen as well, in return, will end up breaking bonds as well. Well, now we just have these lone atoms just sitting around. Well, that's not how they behave. They'll actually form new bonds with one another. Okay, these moving over here, these moving over there, so that we end up having two new water molecules. So these are transitioning into that. Okay, and so how stable they are, will show properties. And water itself is actually very, very stable, which is why you can't burn water where you can burn hydrogen, you can burn oxygen. Okay, the last thing I talked about in class about something that affects the properties of molecules is the structure or shape of the molecule. Okay, let's look at water, for instance. Water has a very interesting shape here. Now, this here is a covalent bond right here and right here, but it's not an equally shared covalent bond. Okay, oxygen's like that greedy older brother who's eating a cookie and your mom tells him to share with you, and so he gives you a chocolate chip, he thinks that's sharing, right? But it's not. So the electrons, they'll actually orbit around that oxygen. They orbit around it a lot. Every once in a while, they'll orbit around a hydrogen, but then they orbit around the oxygen some more, over and over, okay? So because of that, we end up having a negative charge from those electrons up by the oxygen and a positive charge down by the hydrogen, creating a polar molecule. Okay, so this molecule has its own electrical charges as a molecule itself. Even though it is a neutrally charged molecule, it's polar because of its shape, so the structure can impact that as well. Okay, then the next thing we wanted to talk about is being able to read chemical formulae. So the first rule we need to understand when writing down chemical formulas is that when you're writing the elements, the first letter is always capitalized, and if there are two letters, the second letter is always lowercase. Okay, this is an example here. CO is cobalt on the periodic table, but if I wrote CO, that's carbon, that's oxygen, becomes carbon monoxide. So it's CO, cobalt, CO, carbon monoxide. It all depends on whether or not that second letter is capitalized or not, determines what the molecule is. Okay, so that's the first thing we need to understand. The next thing we need to understand is the numbering. Okay, if I have methane, which is CH4, I need to understand how many of each atom is there in the molecule. Okay, we have the carbon. That carbon, there's no number there, so we assume there's just one carbon in that molecule. And then hydrogen, there's 4 of those, which means there's 4 hydrogens in that one molecule. Okay, this drawing right here representing methane. Okay, so 1 carbon, 4 hydrogen in that molecule. Well, if I have a 2 at the beginning, that 2 doesn't mean 2 carbon. If there was, there'd be a 2 there next to carbon. That 2 means that there are 2 of these molecules. Okay, so that means there's not 1 methane, but let me make a copy of this. But 2. Okay, we now have 2 methane for a total of 2 carbon, and then 1, 2, 3, 4, 5, 6, 7, 8 hydrogen. Okay, and so that's how the numbering goes. For naming, you name an element based on a variety of things, but most common is it deals with the elements that are in it. For example, we talked about carbon monoxide. We have carbon, obviously, oxide for oxygen, mon means 1, and because it is a covalent bond, we use the term "ide." But we don't need to know all those things. You just need to be able to recognize, if I say carbon monoxide, you'd be like, oh, that sounds like carbon, and then monoxide reminds me of oxygen, and you can just remember that. Okay, let's see, then the last thing that I covered in the lecture yesterday was the different types of molecules. There's what's called a compound and a molecular molecule, or elemental molecule, excuse me. An elemental molecule is one like hydrogen or oxygen or let's say cobalt, right? These are all elemental because there's only one type of element, okay? Just hydrogen, just oxygen, or just cobalt. Where in return, if I had water or methane or carbon dioxide, these have 2 types of elements within them, okay, making them a compound or a combination of multiple. Okay, that should be enough information to kind of get you started on that assignment, so you can go from there.